Okay, I'll start. Hi everyone, thanks for coming today. Thanks for drinking our beer. I want to tell you about shuffle checks. I will tell you what are they, how we implemented them, and what results did we achieve. First of all, let me introduce myself. I'm Denis. I'm QA engineer in PyCharm QA team. I started my career in IT as a technical writer, and about 1 year ago I switched to QA. I write UI end-to-end tests, and I'm also responsible for manual testing of PyCharm's AI features. This photo was taken in Berlin, but actually I live in Munich, and we're waiting for our train. It's taken near Hauptbahnhof, and I guess you know this place, in case you were interested in this photo. Before we start, I want to ask you a question. Who likes regression testing? I mean, who likes doing manual regression testing? Nobody, perfect.
Oh, I actually know one person.
Sorry?
I actually know one person.
Okay, thank you.
I've seen him once. I think he should be in the zoo.
Okay, I actually expected something like this. If you ask me, I'd say that it's definitely not my favorite QA task, and I find it boring. Doing same things again and again is boring, right? And I also find this activity kind of weird because I'm looking for something, but at the same time I'm hoping that I will not find anything. So I find it strange, right? Because why I don't want to find anything, because I'm actually trying to confirm that the product I'm working on, is good enough. So I don't want to confirm that it's bad, right? So today I'm going to tell you how we managed to make this regression testing process a little bit less painful and more useful. Let me tell you a few words about our PyCharm QA team. We have more than 20 developers. Of course, developers are not in the QA team, but this number is important because developers are the guys who develop new features, obviously, and we need to test these new features. They also introduce bugs, and we need to report these bugs. And the number of QA engineers is ±4. Why ±? Because some people join our team, like I joined 1 year ago. Some people leave our team, and we also have 20% projects, 50% projects. So it's like this number is pretty fair. Last year we had around 4 FTE QA engineers. I don't know if it's enough or not. You know, I'm biased because I work in this team, but please answer to this question to yourself while listening to my talk tonight. Another question to you guys. Who should be responsible for releasing a software product, or who is responsible in your companies? Release managers?
Yep. Engineers.
Engineers, okay. Release managers is a good answer. I would also answer that, but we don't have release managers. And actually we, PyCharm, we QA engineers are responsible for releasing PyCharm. And in last year, 2024, we released PyCharm 70 times. I was proud of this number before I listened to Vasily's talk today. So they are releasing like 200 times a minute or so. But we have a desktop application, right? And these are like real releases. We have user-facing communication and all stuff. But so please, it's not so awesome, but still. And I remind you again that we have more than 20 developers and we only 4 QA engineers. And the goal of our team, I'm not sure that this is, yes. Yes, something is wrong with the slides, I guess. Okay, I will tell you about this slide. So I don't know.
Check the slide.
Yes, I need to check. Sorry. My flow is broken. How come? Yes.
Disappeared.
Yes, it was.
Some regression here.
Okay. It always happens. Okay, I will tell you about PyCharm. PyCharm is a Python IDE. Who of you guys use IDEs? All of you use. Okay, I didn't expect that. I was expecting like QA engineers, but you are. Okay, cool. So I don't need to explain, but I've already prepared for my talk, so I'll tell you that IDE stands for Integrated Development Environment, and basically IDE is a program for writing programs, right? So PyCharm is a program for writing program in Python programming language. PyCharm was first released in 2010, so now it's like 15 years, and throughout these 15 years we were adding new features to PyCharm. We were adding support of new frameworks and technologies, and now PyCharm has like literally hundreds of user scenarios. It's a very multifunctional product, and it's a very challenging product to test. But that's not all. We also have IntelliJ IDEA. IntelliJ IDEA is another IDE. Actually, JetBrains is a company that develops IDEs, right? So IntelliJ is for writing Java and Kotlin code mainly, but other frameworks and languages are also supported. For example, you can work on your Python projects in IntelliJ IDEA as well. And this IntelliJ IDEA serves like a platform for all other IDEs. So we receive features from developers who work in IntelliJ IDEA department. And of course, we need to test them. We need to make sure that they work good in PyCharm. So you can call it like mother IDE. We also have other IDEs like WebStorm, DataGrip, and many others. They are also built on IntelliJ IDEA platform, and their developers also provide features, and some of them also land in PyCharm. So we can call them sister IDEs if you want. And we also have this one. This guy is AI assistant. We also have a lot of features. They're deeply integrated in PyCharm, and we also need to test them. So you can call this step brother if you want. So that's.
Okay, this is why it looks.
That was about our family of IDEs, right? Now let me. I already mentioned that we have done 70 releases last year, right? For me, it's a big number, okay? And now I want to explain you how we have 70 releases a year. This is an overview of our release cycle. Every year we have 3 major releases. For example, in 2024 it was 2024.1, 2024.2, and 2024.3. But before every major release, we have a bunch of EAPs. EAP stands for Early Access Program. And we use these EAPs to test new features on our real users. But in return, our users can use paid features in these EAPs for free. For a limited amount of time, for 30 days. Usually it's up to 9 EAPs before each major release. There are also RCs, release candidates. There can be only one RC or RC1 and RC2. And finally, we have release. And this is our goal of the PyCharm QA team, to have the perfect quality, or a feeling, this perfect feeling of a perfect quality of our product. Something happened to my slides. Now comes this slide that broke my flow. How to achieve this perfect quality? You all know how to do that, but I hope you will agree with me that regression testing is a must. Without regression testing, you cannot be sure that your product is good enough and can be delivered to your users. What is regression testing? Actually, it's just going through a list of scenarios and putting some check marks in some test management system. We also have such a list of scenarios. We call it test plan, quite a common name. Now, test plan. The test plan. I already told you that we have hundreds of user scenarios, and our test plan consists of more than 700 scenarios at the moment. And we use test management system. It's a very reliable one. It's Google Sheets, also known as Excel. But that's not all. We also have a few multipliers. We have different operating systems. PyCharm is available for Windows, Mac OS, and Linux, so we need to test on these operating systems. We have different Python versions. We have different types of Python interpreters, and we also need to test PyCharm on all these environments. And all this gives us a number of about 3,000 regression scenarios. Yeah. Of course, it's impossible to cover such a number of scenarios. That's why we use some tricks. Some scenarios, we check them only on only one operating system. For example, if splash screens are correct on Windows, it's highly likely that they are also correct on other operating systems in the same build. What else? We also have priorities. Each regression scenario is assigned a priority from 0 to 3. 0 is for the most important scenarios, like smoke testing, if you want. So we verify them on every release without any exclusion. And then priority 3 are least important scenarios, so we verify them seldom or skip them for most releases. All of these cheats and tricks reduce the number of scenarios from 3,000 to like 1,000, because there are still many scenarios that need to be checked on many environments. Reminding you again about the PyCharm QA team: 70 releases, 20 developers, about 1,000 regression scenarios, and 4 QA engineers. I think it's a challenging job to do, but we also have other challenges. Let me tell you about them. First of all, this perfect feeling of a perfect product is achieved with regression, and that regression testing, full regression testing, will take from 1 to 2 weeks. Like a couple of weeks would be enough for that number of testing scenarios. And ideally, that should be done on the release build, on exactly the build that will be later delivered to our users. But here come the buts. We have developers who first they introduce the bugs, right? Then they fix them. Yes. We also have product managers. They design and promote new features, and all these guys, they want all that in the nearest release, ASAP, in the upcoming release. Now, question to you guys. Yes, I also have cats in my presentation. Who is the cat?
You.
Yeah. It's yeah. Yes, right. It's QA engineers, and actually it's a junior QA engineer who is asking, guys, please stop pushing your changes. Please let us test the build. So all that results in the fact that we don't have 2 weeks, we have like a couple of days. We don't get the final build that can be delivered to our users until it's only 2 days left before the release. Another challenge is that we have other tasks, other interesting tasks. As for me, any task is more interesting than regression testing. We have to, I don't know, improve our processes, test new features, verify bug fixes. So we don't only do regression testing, right? Another challenge is imagine that you are going through a very long, exhaustive list of scenarios. I will not say you, because you are obviously good QA engineers, because you are here tonight. Some bad QA engineer, bad tester, okay? They are going through a long list of scenarios. They are checking them. And at some moment of time, they see an input field, and they know which value to type into this field so that everybody works. But what if they put in a negative value, for example? And obviously, something will break. But it's not on the scenario, so and they just want to get the job done. This long list of scenarios to be verified, and so they are tempted not to explore, not to put in negative numbers or very large numbers, because nobody wants problems, right? So it's also a challenge when you have so many scenarios. Another thing is that, as I told you, we have hundreds of user scenarios, and PyCharm is a very multifunctional product, and naturally it's impossible to know everything, right? And our QA engineers, they know some areas best, and they have kind of specialization. And that's why when the time comes to do regression testing, naturally we choose something that we know best. And we choose it, and we always verify it in the same way, right? Because we all know how it works. And it's also a problem, because when you verify something always in the same way, you are not seeing other bugs, other things that you would see if you verified it in another way. So I guess you understand what I mean. Another challenge. I already told you that we have like a couple of days before the release, when we have the final build, like 2 days before the release. But of course it's not enough, and actually we start regression testing earlier, like 1 week before the release. We take a build from the release branch, and it is very close to the state of the product that will be released finally. But even when we find something, it's often is not fixed before the release. How come? We also have our limitations. We have code freeze, feature freeze, quality gates, and we cannot push changes, fixes into the release branch 1 week before the release. Of course, if it's a critical problem or a showstopper, developers will put effort and fix it and push it into the release. But if it's like major bug, it means that there is a workaround. So it's highly likely that it will be delivered to users. So it doesn't make sense. We're searching for something, we find something, and it's not fixed. It's delivered to our users. To sum up, here are the challenges. First of all, we don't have weeks, we have days to test for regression testing. We also have other interesting tasks. We are too busy to explore some side scenarios, and we are also too busy to communicate, which is also very important. You know, the communication is the key. Asking teammates, product managers, is it a bug or a feature? So you need time for that. Also, specialization means bias. We are biased because we know our things and doing them in the same way. And it's often too late to fix. So when we find bugs, they are often not fixed because it's too late. What did we do to overcome these challenges? I'm not sure who was the first one who mentioned this idea. It was kind of in the air. We have these priorities, and it would be natural just to mix them, to shuffle them, to randomize them, so that scenarios that had, for example, priority 3 become of priority 1 for some time, and we verify them more often. But we have Google Sheets, right? And so it's not an option for us because we just copy them, duplicate these sheets for every release, and we will be lost. We will not. We will no longer understand. We would no longer understand which scenario had which priority initially. That's why we wrote a Python script. Of course, Python script because we're working on Python IDE. This script generates a bunch of scenarios, randomizes them, and generates like a batch of regression scenarios. And then we verify these batches of random checks on every EAP release until we get to the major release, and we have this feeling of a product, of a perfect product. How did we integrate these shuffle checks into our processes? So I need to tell you about our processes. The process of releasing, we call it housekeeping. You can also call it housekeeping. That would be also correct. It's a very complicated process. There are dozens of actions, many things you have to keep an eye on, many Slack channels, and so on. But in a very simplified way, it consists of 4 main phases. The first phase is changes, so you need to figure out which changes will be included into release. Then you need to prepare the release build. Then you need to test to verify the release build. It's not only by the way, we call the QA manager who is responsible for releasing housekeeper. And we do it in turns because nobody likes doing it. So this verifying the build, it's not one person who does this. We do it as a team together. And the final stage is deploy, which means make the release build available to users. On this stage, when we verify the release build, we usually create a so-called QA thread. It's a Slack thread in our internal Slack channel, and we use this thread to exchange information about failures and defects that we find in the build. So we all use different operating systems. You can ask your teammate to try to reproduce it on Windows to see if it reproduces, or maybe your teammates already know this problem and can give you the number of the issue in our bug tracker. So it's for communication, and the main question that we need to answer in the end is, shall we release this build, or shall we report problems and wait until they're fixed, which means postpone the release for a couple of days. This is the main question. Is this build good enough to be delivered to our users? This is the main question. And this QA thread is where we introduced the shuffle checks. This is how it looks like. This is a QA thread, actually. I will explain you in details. The first message, now it's done automatically by the script. Before it was done manually by a QA engineer. So there is a link to download installers. So you can just click the link and choose your operating system, download it, and start verifying the build. Link to the checklist. This is the Google Sheet for this particular release. So you just click it and start putting your check marks. Link to automated tests. We have a bunch of automated tests, and they are also run against the release build. So you can also check them. If they are all red, it means that the build is very bad and it doesn't make sense to continue with testing it. Emojis are very important. Why? Because we use them as our commitment to go through the regression scenarios on a specific operating system. Like here we have Windows and Mac OS. So when you put this emoji, it means that you will go through the regression and your teammates don't need to they can do other tasks. Then comes the first message in the thread, and it's actually the shuffle checks. You see that it consists of some chunks. Here we have 4 chunks. They are generated by the script. They are actually subsections of our test plan with priority. And again, emojis are important because they mean that somebody has committed to perform these shuffle checks, the chunk of shuffle checks. And then goes the usual part where we discuss, where it's blurred out because it's all in Russian, where we discuss the potential problems. So, and you see there is an error message. And finally, we decide if the build is good enough and can be released. What did the team think about all of it? Of course, when you have some amount of work and you are doing it, and then somebody comes and tells you, please do more, nobody would be happy. But I will tell you how we work with these objections. First of all, there is no deadline. So we verify the build for EAP release, for example, in a few hours. It takes us a few hours. But these shuffle checks, they don't need to be performed during these few hours. Usually it's around 1 week between EAPs. So a QA engineer can choose any good time for these shuffle checks and verify them within a week. So it takes off the pressure, right? Another thing is that we will have less work when the major release comes, and it always comes. So, for example, in EAP1, we do this. We verify these scenarios, EAP2, so it goes like that. And by the time of release, you will only have to verify what's left, so you will have less work. Which results did we achieve by this experiment? So we lived with it for 1 release cycle, I mean 2025.1, and we managed to detect 8 issues. 2 of them were criticals, and this is the main number. 5 of them were fixed before the release. Otherwise, they won't be fixed, and our users will get those bugs. So early detection means just-in-time fixes. In our case, it works. Also, less routine means less bias. I already told you that these scenarios are randomized, okay? And you never know what you're going to get. And if you come, if you are late for the party, so you get what is left, and you have to test what you have never tested, and naturally you will test it in your way, in a unique way, and it's like 90% that you will find something, find some bug. That's how we found that our users could lose their ability to use Python 2 in PyCharm. Python 2 is quite outdated, I'd say, but still many our users need it for their legacy projects, and it already was not supported normally, so there was a workaround to use Python 2 in PyCharm, but our users could lose even that workaround. So we found it and fixed it, all thanks to the shuffle checks. And increased coverage. First of all, this generated by AI, okay? So AI thinks that it's 70%. What do I mean by increased coverage? I already told you that there were a lot of, like, hundreds of scenarios, and it's also natural that we skipped some of them. So we didn't cover 100% of them. But in the release cycle 2025.1, we managed to, by using shuffle checks, we managed to decrease the number of regression scenarios that were left to the moment of the major release by 30%. And in the current release cycle, we are planning to increase this number to like 40-45%. So it means that by the time of the major release, we have only 70% of scenarios to verify, and we will skip less, right? And we will cover more. This is what I mean by increased coverage. To sum up, here are the results of this experiment in the PyCharm QA team. We improved the coverage, we reduced routine bias, enabled earlier problem detection, and we freed up time for exploration and communications, which is very, very important. In case if you want something similar in your processes, in your team, in your company, I prepared a short step-by-step guide. It's very easy. First of all, you need to create a list of your regression scenarios, Google Sheets or Excel.
Or TMS.
Uh,
A real one. Real one.
Yes, it's our sponsor.
Oh.
But no, actually, Google Sheets and Excel are enough for the task. And if needed, you can also test. You can add environments if you have, for example, different operating systems. You can add priorities if you want. Then export this to CSV or any other machine-readable format, but CSV is also good enough for the purpose. Then here comes the AI. I only mentioned this word once today, but here comes the AI. Use any LLM to write a script. Here is the prompt that I used, so it's very basic actually. And then this is important. Use Git for tracking. So use Git to track which regression scenarios have been already covered, have been already verified in order not to test same things twice, right? And it's also very useful if you are working in a team, in a distributed team. Just commit and push your changes. Here is the video. No, I want to show it, please. Okay, it's basically the same. It's a non-existent picnic table booking application. So it's a list of regression scenarios. Then you add environments and priorities. Export as CSV into PyCharm project, of course. You can use PyCharm. We have a free trial. Use AI system to generate the script. The free trial includes free AI quota. It's not large, but it is enough to generate a simple script. So the script has been generated. Just copy it into the project. Yes. Then I guess, yes, the most important part, put the project under version control. This is how it's done in PyCharm. You can use terminal for it as well. The project is under version control now. Now we run the script for the first time. Of course, it doesn't run because we need to specify batch size. This is like the number of chunks that you want in your shuffle checks batch. Here are the shuffle checks. You can copy them and to Slack or use it in any way. Commit changes and push them if you are working on a team. So here are the release, the regression scenarios that have been verified. Let's pretend you have alpha 1 release. So that's it. Let's connect on LinkedIn. Please scan this QR code. Connect with me. I will be happy. Thank you. Do you have questions? Yes, please.
Yeah, thank you. It's